This tutorial will focus on collecting high-quality image data that is optimized for PIV analysis. A future tutorial will go into detailed PIV analysis techniques. But first, if you have not already, please watch our first SpinLab tutorial, EduPIV System Setup and Data Collection. There will also be relevant links to this tutorial throughout the video. Criteria that affect the quality of an image. The first parameter is particle density. This is determined by the volume of the water in the tank and the amount of particles added. Essentially, there needs to be particles in every pixel of each image. The second is the thickness of the light sheet. This is determined by how far the light sheet optic is from the bottom of the tank. On the left, you can see that the light sheet is too wide, illuminating too many particles because the optic is too far from the tank. On the right side, the light sheet optic is too close to the tank and the light sheet is refracted. The middle shows a thin light sheet, best for collecting PIV data. To adjust the light sheet optic, loosen the screws pictured and move the optic up or down. Next, the distance between the camera and the edge of the tank needs to be such that the entire desired area of measurement is captured. You can see that if the camera is too close to the tank, the particle motion we wanted to measure is cut off. Here, you can see the entire measurement area we are interested in has been captured because the camera was moved further away from the tank. Exposure time determines how long the camera shutter is open and thus affects the brightness of the image. You can see that a lower exposure time darkens the image. Adjust exposure time as shown. Lastly, the camera's trigger rate determines how many images the camera captures per second. The ultimate goal for your optimized images is to have a relatively bright image using exposure time that has the least amount of particle streaking by adjusting the trigger rate and captures the particle positions. The density of the particles makes it possible for the flows to be captured by the camera, and the light sheet determines how thick the layer of the particles being imaged is. In the streaking image on the left, you can see that the particles are oblong instead of circular like the particles in the image on the right. Before we continue, it is important to note the relationship between exposure time and trigger rate. If you increase the exposure time, the risk of particle streaking increases. If streaking is an issue, increase the trigger rate to take more images per second. In fact, the trigger rate limits the exposure time. For example, if you have a trigger rate of 100 images per second, then the trigger period is 1 second per 100 images, or 10 milliseconds. The exposure time cannot then exceed 10 milliseconds. Furthermore, for the EduPIV system, the FlowSense camera can only take up to 160 images per second. The big takeaway here is that you must find a balance between brightness and streaking, aka exposure time and trigger rate. This is how we set up our system to get high-quality PIV images. Our particle density was 0.5 grams of 50 micron particles for approximately 18.6 gallons of water. We put the light sheet optic as close to the tank as possible before the light was diffused by the tank, approximately 1 centimeter from the bottom. The camera was 55 centimeters from the edge of the tank, and it was in its highest possible position. Our exposure time was set to 3,000 microseconds, or 3 milliseconds, and our trigger rate was set to 160 Hz. The vortex generator was set to a medium fast frequency at W1 with 20% speed. The settings are shown here. The aperture of the camera was fully open. Finally, if possible, turn off all ambient light so as to not interfere with the illumination of the particles. With those settings, acquire images as shown in SpinLab tutorial EduPIV system setup and data collection linked at the beginning of the video. We acquired 300 images to analyze our vortices. These are our imaging results. Analysis of the data collected will be in the next SpinLab EduPIV tutorial.